Well, hi, good morning, and welcome to my shop, and thank you so much for joining me here today. And it's November 9th today. Very sunny outside, sunny and cold. Clear sky brings cold air. So very nice and sunny though. Whoa, scared me. Okay, a few more capacitors left in here. One here, one hidden way down under here. The one that's hidden way down under here simply is the one that receives external antenna input if you do that. I'm not sure if I need to change that or not. I haven't decided what to do about the missing AM broadcast antenna. I've got a couple ideas about that. I think it's a very important component, and to not have it in there. So I think what I'm going to do is really only this one. There's this big guy, which I'm leaving to the end, and like I say, there's the one hidden back in there. Is there really? Yeah, there really is one back there. You can probably change that, even though it's right in behind here. So my attempt to determine which capacitor or capacitors are affecting the strange behavior of the radio, and maybe I shouldn't even say strange. Maybe it's totally normal behavior. With all these mysterious signals running around inside the radio, again, the only ones we hear are the ones that match the IF frequency and will come through the rest of the radio. So perhaps they are just without consequence. Sure seems to be the case. I've encountered them in numerous radios, but to varying degrees, which catches my attention too. Why don't we find out what this capacitor is and if it has any possible role in the situation. Likewise for the one down there. Well, then I'll change those two, and we'll see. Maybe in the end it's going to be this big one that's really helping the situation out. I kind of doubt it though. I'm always kind of surprised by this. So see these two capacitors here, they've come out of my tray. See the sizes there, 0.015, 0.0015. I need the smaller one, 0.0015, to replace the guy back there. So the two capacitors look like that. You want to take a guess? You know, I wouldn't be showing you this if the smaller capacitor was the smaller capacitance, but it isn't. This is actually the bigger capacitance. This is the small guy. This is 1/10 the other one. Plastic covering here is coming right off. Okay, I don't think it's a problem though. I'm going to put that capacitor in. Okay, let's get the capacitor test that I took out. Now, you might be asking yourself, why do you bother testing these capacitors? They're all bad, and they pretty much are. It's very seldom I come across a wax capacitor that can hold up to the higher settings on here. Very seldom. But doing this keeps my feet on the ground. Okay, so I'm not living in my imagination where I imagine these capacitors to all be bad, and I just do stuff based on what I imagine to be the case. And the other one is the person who owns this radio can be watching these videos, and they're interested in seeing proof of my claims. So here it is. So this is the capacitor that was in line with the antenna input wire. And yeah, pop right open. That looks very good. Speaking of good capacitors. So this is the best one coming out of this radio so far. That's 150 volts, and the pi is almost open, but I'm sure I put 250 on here. I'm just looking for the rating on this guy. I don't see it. Well, I'll let him have it because he's going for the garbage anyway. So it actually opened a little wee bit. So this particular capacitor is actually in pretty serviceable shape. Probably could have left it in. Oop! Probably could have left it in. Sorry about that. Camera slipped off. So that's why I do all this testing. Plus, what I'm trying to maximize in this shop here, by the way, is actually fun and interest for me. So I do things in a way that I find fun and interesting. And hopefully you who are watching finds it kind of fun and interesting too. And now we're down to, so that guy's gone, we're down to this one. This one and this one, we got to look at these two on the schematic again. They seem to be working together or in opposition. Maybe not opposition. Let's take a look. So the two capacitors, this one's the small one I'm about to change, and then this is the special one, a large capacitor, 0.2, with a coil wrapped around it. We got to investigate this a little bit more. Last time I did one of these radios, I looked into this and found out this was, I think, an attempt to make this resonant at the IF frequency, but I can't remember now. And the idea is somehow it makes the radio work better. So we'll look into that too. So, but look, why 0.002, and it's straight in parallel with this thing? You got to wonder, what's this thing for? That they need this little one here too. I'm certainly wondering. Okay, let me look into this a little bit. So I thought the first stop on my investigation, or my repeat investigation of this kind of special Philco capacitor, would be to ask an AI system about it. What would an AI system know about this capacitor? Well, you'll be surprised because I'm going to show you here. So here's my question right here. And it's not even a well-written question. Here's what I asked it. I'm fixing a Philco tube radio and there's a special capacitor in it that I'd like to know more about. This 0.2 microfarad capacitor has a coil wrapped around it made up of 9 turns of wire. It's installed between the B- bus and the chassis. There's another 0.02 microfarad capacitor in parallel with the special capacitor. That's all I said. This is what it said back. It sounds like you're dealing with a Philco special capacitor, which is designed to act as a series-tuned circuit. This type of capacitor with a coil wrapped around it is often used to improve bypassing characteristics and reduce unwanted feedback at the intermediate frequency stage, typically around 455 kilohertz. The coil around the capacitor helps to tune it closer to the IF frequency, enhancing its effectiveness in filtering out unwanted signals. This setup is particularly useful in older radios where the construction of capacitors could introduce significant self-inductance. I've never heard that before. In your case, the 0.2 microfarad capacitor with the coil and the parallel 0.002 microfarad capacitor work together to create a more effective filter. If you need to replace the 0.2 microfarad capacitor, you can use a modern capacitor of the same value and, if necessary, replicate the coil by winding 9 turns of 20 or 22 gauge wire around the new capacitor. If you have any more questions about your Philco radio or need further assistance with the repair, feel free to ask. I do feel free to ask already. Well, so there's a line in here that I don't think is quite correct. This one here. The coil around the capacitor helps to tune it closer to the IF frequency. I think that's true. Enhancing its effectiveness in filtering out unwanted signals. That's the part I'm having trouble with. Maybe it's enhancing its effectiveness in not filtering out wanted signals. I think that's closer to the truth. After all, if this thing is tuned to 455, then it generates a high impedance. Let's look at the it generates a high impedance at the IF frequency. I guess you could argue that keeps the IF signals from reaching the chassis through here, but they can go through this one. Or is it a small guy? It may be sized. You know, I think the engineers wouldn't put these in willy-nilly. They're picking these sizes very carefully. Well, what should I do now? I can attempt to measure this capacitance here. I could attempt to measure its resonance. That's kind of a long shot, but maybe I could. I could change this one without too much consternation. And we could look and see. I could change this one, and we could look and see what happens to the wild signals. That's about the best I can come up with. Now, why would you be concerned about the IF frequency passing through this capacitor? What are we on here? We're on the B minus. It's the B, of course, B minus connection to the chassis. I don't know exactly why this would help. I don't know how important this is in the operation of the radio. It's problematic for me to change it because at 0.2, I don't know, do we even have one? Let's try this. We'll change this, see what happens to the radio, then we'll make attempts at measuring this, measuring its effect. Is it still resonant? All that kind of stuff. Let's see what we can do with it. Okay, that's a plan. Follow the plan. I got a plan. Okay, so this is the small capacitor I just took out. And we'll start with 50 big voltages on it. Here we go. Popped right open. Lovely. How about this? Very similar to the last capacitor. What would be the significance of this one leaking like that? I don't know. That's what I'm trying to find out by doing experiments and poking around here and there. Okay, we're going to operate the radio now. See that the funny fuzzies are still in there, running around. And then we're going to deal with this guy who I've been saving right till now, in fact. Okay, well, I'll get that ready to go. This is on the Radio Museum website. How to make a Philco special capacitor. And he goes through explaining how to do it, and it's really quite simple. You take a capacitor, wrap the right amount of wire around it, which is something to be considered. Do some testing to bring its tune point to 455. There he is doing it and checking it and doing all this. There's the finished product from this guy. Look at this. Look at this statement. That's why I'm showing you this statement. I tried a UL rated safety capacitor with a smaller value, but Birdie's harmonic interference appeared across the band. I remade the filter with the original capacitance of 0.2 and all the Birdies were gone. Birdies. Well, it looks like it's up to this capacitor to solve the problem with this radio. So let's turn our attention now to determining if the capacitor is in bad shape or not. We know from testing all the other capacitors that they were all leaking to some degree. And I can only say some degree because the test I'm doing is just a qualitative test. I really don't know the degree to which electricity can leak through one of those capacitors. I suppose if we did a little research, or maybe if I ask the AI that question, it'll come out and tell me. But I'm not going to bother. How can we test this guy? So there's one lead here, one lead there, and the coil is attached here to this end of the capacitor. So it's a series circuit. This is easy to lift. I can lift this off real easy, this wire, leave everything just as it is, and then perform tests on the capacitor. That's what we're going to do here. I'm probably on my way to replacing this in any case, but I'm going to take it one step at a time here. Oh, I never tested the radio after changing this capacitor. Oh well, I'm going to move on. Going to move on because I think it's all about this one. Did I cut the wire there? There we are. Okay, how to test the resonance on that. I got to set up a little circuit here. Okay, not sure how well this is going to work, but what I've done is I've soldered on a low value resistor here, 10 ohm resistor, and I've got my oscilloscope reading the voltage across the resistor, and meanwhile I've got my sweeper sweeping across the coil and the resistor and the capacitor together. I'm thinking this is going to give me the result I need so I can spot the resonant point for the capacitor. Now in some cases in these Philco radios there'll be a special capacitor, but it won't look much different than a regular one. You won't see this coil on the outside. The coil is hidden under a cover, and so it ends up looking like an ordinary capacitor. So watch out for that. This one's kind of nice because it's right out in the open. I mean, there's no question what's going on here. So I'm going to flip now to looking at the oscilloscope here, and we will see what we see. So what am I doing here? I'm sweeping from, let me stop the sweep. So you see the line on this side. That represents 320 kilohertz. And if we look at the other side, that's way over here now, almost off the screen. That's almost 500. So I'm going right through the IF frequency. Is going to be right in the middle here. Okay, let's let it sweep. I don't see any resonant reaction whatsoever in this. Which might mean my test is incorrect. I'm on the 0.2 volt scale, putting out a fairly strong signal here from the sweeper. That's me moving it up and down. You see any sense of a curve in there at all? No. So either it's resonant at a much different location. Let me go down. So what's happening is this is starting at a lower and lower frequency here. Do I see a slight curve here? Ever so slight? What am I down to? I'm starting now at 200. Let's go lower. I'm having trouble going lower. So this is just the end of the sweep here. That's what you're seeing there. It would look like it's just, it doesn't look like anything. Let's go higher. So I'm gonna raise up this end now in frequency. Aha. There it is. What frequency is that? Good question. So now we are sweeping between 4,000. We're sweeping, it's virtually zero here. And we're going all the way up to a lot higher than I thought. Going up to megahertz. Okay, yeah, that makes sense for the way the settings are. So 0 to 1 megahertz, so this is 500 kilohertz here. So I'm going to try to focus in on the 500 with my settings here. So we're going to, just bear with me here, stop. We're going to raise the start to 450 kilohertz. Actually, let's go a little bit lower because I don't want to go across the IF. So that's now 420 kilohertz. And the other side we're going to bring down from 1,000,000. Let's try 590. So we're going, what are we doing? We're going 500 to 590. So 500 to 6. There, you can see the curve right in here. So we're aiming for 455 with this resonant, and look, it's not much of a dip. I mean, there's hardly any reaction here. But that could be because that could be because of lots of reasons. I won't suggest any. So is this an accurate representation of the effect of that capacitor? It's virtually nothing. There's virtually nothing happening there. Is there another resonance way up higher? Way up higher? No. It's rolling off here, but it's rolling off just from ordinary stuff. Well, let's see. If I put this kind of in the middle, it's sort of in the middle now, and this is 0, and this is now 675. I don't know. I'd have to put another frequency in to detect that. Is this the reason? Well, let's put it this way. Is this how this is supposed to work? I don't think so. I think the resonance in the wrong spot, and I don't think there's much going on here. So either my test is bogus, or that's possible. If I move my I can't really do that. I can reverse it. I can reverse this whole test setup here. What I'll do is I'll just flip everything around the other way. So take this, I'll just move the ground to the other side. In effect, then I'll be looking at the signal across the capacitor instead of across the resistor. And doing it differently may highlight some. Whoa, that's really, yeah, totally different. What do you make of that? Wow, that's pretty crazy. Let me increase the frequency here. Oh, this is not at all looking like any kind of resonance here. Let me lower this side. Well, oh, I'll take that back. That's pretty distinct there. Okay, let's set this up now. So the starting frequency is 144 kilohertz, and the stop frequency is, it's a megahertz. It's way up there. Let me bring it down to, I don't know, 380. What happens now? Well, we can still see the resonant point here. Pretty broad, eh? What exactly are they trying to do here? You're trying to make the impedance of this part of the circuit drop to next to nothing at 455. And then out, and then what? And then I don't know. Let me just raise this up a little higher yet so we can put that right in the middle. So we have the point in the middle now. And I don't know that this is valid at all, what I'm doing. You know, you can do these tests until you get the answer you want, and then you walk away. That's a big problem. So we start here. This frequency is 144 kilohertz, and the other end 580. So let me get my calculator here. What's in between 144? Lousy calculator. 144. And we're going to add. No, I want no. I'm doing this totally wrong. Goofball here. Let me do this. Put that in. 580. Oh, what am I doing? You know what? I think it's time for coffee. Time for coffee here. Let's let this thing sweep along while I'm going and drinking some coffee. Okay, so I'm really in territory here I've never really experimented very much with, so there's a good chance what I'm doing is actually not functional. So I have another signal generator going, produces a single frequency. That's the frequency it's at right now, 567 kilohertz. And I still have the sweep generator going, and we're gonna take. Oh, also I've been fooling around here a bit. Now I've got all the ground connections at this end, and I've got the scope still in the middle. So now the scope is looking at the voltage across the capacitor itself. And this resistor, tiny resistor out here, which I think really should be much bigger, but oh, well, that might explain something right there. I think I was grounding out all this time. That might just help things out. Okay, so let's take a look at the scope here, and something strange is going to appear. I might just get a little better focus if I pull back a little bit here. So what we're looking for is an indication of the other signal generator in this thing, and I can see it. It's just above my fingernail here. You can see a slight quiver. I can see it. You can't really see it. Let me see if I can just. So what the camera sees and what my eye sees is a little bit different. I don't think I'm going to be able to. You're going to have to trust me on this. maybe you can see the tiniest amount of quivering right here. Especially if I take my finger away. I got no more juice to supply from the other signal generator. It's full tilt. So there are some weird things happening. You may have just seen kind of a like I'm bumping a wire. Some stuff is jumping. You know, there's a lot of problems here. I don't know why this is jumping like this. Nothing seems loose to me here. Oh, another short was happening there. Maybe that's what it was. Okay, now I'm going to change the frequency. I'm going to try to move the pip right to the center here, which looks like the resonant point of this capacitor and coil. So I'm going to move it there. Okay, so it's right at the bottom now of the valley. Again, probably very hard for you to see. You might see just a little shake on this line here. So I believe I'm now marking the resonant point of what I've got hooked up here. That's the best thing I can say. What is that frequency? 650 kilohertz. 650 kilohertz. This doesn't make sense. Not making sense. Something's not right here. And the reason is the top frequency here at the very top of this is, I'm just checking, 578. So the sweep isn't even going past 578, yet somehow I'm marking this as if it's 647. What if it's half that? Can it be half that? So 647 and half is 320. I'm going to dial down to 320. See if another one shows up. This will make more sense actually. Okay, coming down 320. Just my output fell off a little bit, so I'm looking very carefully now for any indications on here. There is nothing. Okay, so I'm going to go right down as low as I can go here, 295. Just going to go up and keep an eye on that. I'm going up. I'm at 329. Going up. This is definitely weird. 400, nothing. 450. So you know this would be the magic. If it showed up now, that would be great. Getting 500. I can see it now. It's right here. And if I take that mark down to the middle, so anywhere in here, 650 again. What is going on? I often ask that question. I mean, basically this can't be. This cannot be. Again, just double checking where the sweep is ending. 570. So this is 570. And yet my other signal generator is suggesting this is 640. Well, this didn't work out at all. I mean, I'm almost lucky in a way, because if these two things had kind of jived, I would have gone, yeah, that's it. You really don't know that that's it till you've done things a couple different ways. Wow. Wow. Okay, what am I finding out here? I don't know. I'm finding out I don't know how to measure this correctly. I mean, one part of this capacitor is still in the circuit. Why don't I just take it right out entirely at this point? I can always put it back in, as long as I don't damage damage it in some way. Okay, that's what I'm going to do. I'm going to take it right out of the radio here, and we'll play with it right on the bench. Okay, well, I've got the capacitor and its coil here. I've got my test resistor there, and the scope connection. My scope's on ×1. Okay, let's take a look at what's going on with the So it looks pretty much the same as it did before. It doesn't look any different. And the other signal generator wiggle is right here. It's a slightly different location. Oh boy. Okay, I'm going to put it right in the middle. So this is 645 where it is now, right here. And if I put it in the middle, right on the line there pretty well, 700. And the sweep is not going up to 700. Wow. Okay, that's a strange thing. That's the times 10 difference there. Times 1. Okay, just moving stuff around. Oop, clip lead came right off. And my scope lead is off. Let's look at the... I have to flip this all around here. Okay, hang on a sec. Everybody hang on. I'm going to flip this whole thing around. So again, we're reading this time across the resistor. Small resistor. I put a very small one here because the guy I was reading on the internet was using a 1 ohm resistor. And that sounds crazy to me. So I've got a 10 ohm in there, which also sounds kind of crazy. I got 100. 100 waiting, just in case. Okay, so what do we got going here? So we have 2 signal generators feeding in here. We have the scope reading across there, all the grounds at this end. If we look at the scope, there's not much to see. What happened to you, scope? Much higher voltage reading now. And no sign of any resonant thing at all. That's kind of how it was the first time I tried it this way. So I'm going to change the resistor now to a 10 ohm resistor. Not that that's much different. 100 ohm resistor rather. And I'm just going to kind of hold it in place here. Hardly see it. You can see interferences here, here, and here. And they're almost certainly coming from the scope. I'm just trying to make a more permanent attachment of these wires. More permanent temporary. Oh, almost had it. Permanent temporary. That was a phrase we used all the time when I worked in the power company. It'd be an emergency, you'd have to run out, get the lights back on, so they do something temporary, and then the temporary thing is still there 7 years later. So we called that temporary permanent. Yeah. You know where you see that? You got underground street lighting on your street. And as you drive down the street, you'll see there's no wires going to any of the street lighting poles, and then all of a sudden there's 2 poles with overhead wires. And what's happened is the underground wire has failed. Guys have come out on the emergency, just kind of hung a wire between poles in order to get the street light back on. Temporary permanent. That's what that'll be. So as you drive around, look for this stuff. It's exciting. Okay. What am I going to do here? I'm going to change the frequency on the signal generator and watch these little pips, which you can kind of see them. Yeah, you can see the effect there. Okay, here we go. Going down, and they're all moving. They're all moving down. Oh my God, what is going on? I haven't got a clue. I'm quite clueless. They just keep coming. They just keep marching up here. Well, this isn't working at all. I'm not getting any sense of anything out of this. Let's go back across the capacitor. Actually, let's go drink coffee for a little bit. Something not working out about this. Okay, let's take a look at this. Same circuit, same thing. All I've done is I've maxed out my sweeper here. So this is up around 5 million hertz up here, and you can just see this continually coming down. I'm I suppose this would curve. It's funny, it's not really a smooth curve, is it? It's like a series of straight lines. But in any case, what we're seeing here, I think, is just the reactivity of the coil. There's the higher frequency causes more and more voltage dropping across the coil. You know what I never did? Hey, okay, I think I just realized my mistake here. I've never looked right across the capacitor or right across the coil itself. And I'm sure this would interfere with the operation here. And how come this ground isn't connected? What's going on here? I got a ground wire off. Didn't make any difference. So I imagine this would go up, 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 and then with the resonance of the capacitor would start increasing. Just, you know, as this is falling. Okay, what am I just muttering here? You know, I can't get this to go any lower. That's the bottom of the barrel there. So it never forms the resonant circuit under this particular way I'm testing it, which could be bogus. Okay, lots of bogus stuff here. Let me, what am I doing here? I feel like I need more coffee. Let's put this like this. Okie doke. I'm going to move the, this is a problem here. So, okay, let me stop and get some things sorted out. So what I've been doing is just trying different combinations of nothing more than the sweep generator, that's this guy here, and the scope here. Just different combinations, just to see what will happen. We're reading across the capacitor, reading across the coil, doing whatever. Look at what I managed to get onto my scope here. Whoops, this is just really disturbing. I guess. I know it doesn't look all that good on what you can see, but look what is going on over here. That the bottom comes up. I'm not moving. It's doing this on its own. So I'm just totally beside myself. Let me just shake a few wires here and see what happens. A little more stable now. But still has this. This is really weird. How do you explain this? Both the top and the bottom going up. Oh, and then this looks like a resonant point. And this is way up in frequency. This is way up 4 megahertz or something crazy like that. So I'm going to bring this down from where it is now, close to 5 megahertz. I'm going to bring it down, way down. Okay, so now this is 1 megahertz here. And let me just check, the stop frequency is 9 kilohertz. Very low. And the top frequency is, whoops, 96 kilohertz. That's way too low. We need to be up here. Okay, so now, see, there's it's very hard to see. I can do this. It looks like it's a little tighter in here than out there. But again, I mean, really, what? What? And again, stop frequency, 1,000,000. So that's 1,000,000. So that's 500, roughly, very roughly. I don't think this thing is doing anything of any significance here. But I also have great doubts in all the tests I've done. Every one of them I'm doubtful on. It's not giving me that good feeling. Let's measure the capacitance of the capacitor. Hey, there's an idea. There's an idea. I could even put the high voltage test on this with the coil still intact. Okay, let's try this guy here. Now, if this capacitor is leaky like all the rest, and it almost certainly is, then this test will read high. Okay, Mr. Capacitor, what does this guy tell us? So this says the C is 317 nanofarads. Now that would be 0.3 microfarads. but it's supposed to be a 0.2, so it's reading high. So a little bit of internal resistance, if you like, in the capacitor, and that's enough to just wipe this whole thing out and turn it into junk. Still not getting that good feeling. Okay, I have the capacitor there connected up, ready for the test. We will see what happens. So 50 volts, first test. And it's coming open. It takes a while. It's a big capacitor, so you gotta let it go for a while. So open about halfway. Again, it's a qualitative test, so I really don't know what to say about. Here, let's just try this now. Not gonna open. Not at this voltage. So, jeepers, what does that tell you? It tells you it's not perfect. What have we found out here? We found out I cannot find a resonant point in this arrangement. I cannot find that it's resonant. If this is really a capacitor with a resistor inside now, because it's leaky, then I think all that would do is just reduce the Q, or the quality of the resonance here. I mean, the resistance would interfere with it. So you'd still see a resonant point, and I think it would be in the same place, just greatly reduced. In terms of the operation of the radio, we see all those bugaboos running around inside it. We got a comment on the internet from somebody mentioning that the idea of this is to stop that. I think that's basically what he was saying. He made a new one. I mean, I can see the turns here. I could probably slip this, maybe not, slip this right off this capacitor right onto another one. Or, as I have seen many people do, just put in a new capacitor and don't sweat over it. So I guess the deal is, if you don't put in a resonant circuit, you're not going to get a drop to zero anywhere. It's not going to be like that. And if you get the drop to zero to happen at the IF frequency, then great benefit to the receiver. Also, some of these special capacitors, by the way, there isn't a coil at all. Instead, Philco figured out a very clever way to build the capacitor itself and utilize its own internal inductance to create the same resonant situation. So some of these you'd have to look real hard to tell there's anything funny going on. Oh man. Okay, I'm going to stop for a bit. Don't know what to do. Okay, I'm back from internet land. There is a ton, of course, written about this capacitor. All kinds of people like me have come across it and done various things, good and bad, to it. One of the recommendations is just put another 0.2 in and don't sweat over it. There's a comment that a 0.2 at 455, if the frequency is 455, then the reactive impedance of this is less than 2 ohms. So if it's already at 2 ohms and you're putting this coil on to try to drive it down even lower, 2 ohms, I guess that's what's going on. So for one recommendation, put a 0.2 in there and don't sweat over it. We could do that and we could see the effect on the radio. Another one is, because this particular capacitor has the coil wrapped on the outside, you can count the turns and remake it. They can even push this off, stick a new capacitor in. Do I even have a 0.2? Do I even have a 0.2? I probably have a couple 0.1s. 0.2. Okay, I'm going to look and see what I got here. And the answer to that question is yes. I've got this is a new old stock. This is a 0.2, 0.15. It's a little smaller. This is a dirty old stock, rolling around in somewhere for years, getting dirty. This is a 0.22. This is roughly the same dimensions as that one. This one's a little bit smaller. You can never slip this coil onto here. I think we should do a series of things here. One is check this guy and see if it's any good. Stick him in with no coil and see what happens. We've been watching those signals all this time, so we're quite familiar with them. We would know if they disappeared. So this is saying it's a 0.27 microfarad, not 0.2. And I'm going to put this on the high voltage tester. No use putting in an already bad capacitor if that's what the situation is. But I bet you this guy tests really good. Let's see. It's a 400 volt capacitor. Okay, we're all set here. 50 volts. What do you do? Yeah, it's not going to open all the way. And 150, it's not going to open. This is not going to go there. Too bad, buddy. You got old. You know, just laying around and you got old. It didn't even have to be in a radio. Just doing nothing, getting old. Hey, come on, camera. There we go. Oh, what about this one? Well, this one, I gotta test this guy too. So, oh, wait a minute. I better look and see if I can find another 0.2. Okay, so this is the 0.15 slightly smaller capacitor, and I'm going to give it the test. And here we go. 50 volts. It opened right up. 150. Open right up. So this is in like new condition. 250 volts. Open right up. There's nothing wrong with this guy. So even though it's coming out of my junk box, it's never been installed anywhere. You can tell from the long leads on it. So I'm going to put this in, and we're going to find out if this alone quells the issue. We will see. It raises a really interesting question about all these capacitors and what kind of resonant point they might have if they have one because of internal inductance. Something I've never really thought much about. Okay, I'm going to put that in there. Maybe that'll be the end of it. Okay, let's see what happens here. SDR antenna. There's the capacitor. I just tacked it in case I'm going to remove it. Put this like this. And we have hooked up to an outdoor antenna for fun. And I need to set some more stuff up here I didn't set up yet. Whoops. Okay, there's our SDR screen with the familiar stuff on it that is on it no matter what. And just to prove it again, I'm going to disconnect the SDR antenna briefly. Yeah, nothing's happening. So that stuff is not coming from the radio. Now we're going to turn the radio on. Volume there. I do have an outdoor antenna on it. Away we go. No, we don't. Didn't plug it in. Let's try again. That time we're going. This light really pops on bright at first. I think it's going to beat it to death. I don't think it's going to last. We will see though. Well, no, we won't see because this radio will be long gone. Oh yeah, what's happening? Oh, it's just full of stuff.
Is accommodating you and making this okay for you. All they want to be able to make a determination.
Yeah, all the same stuff is still there.
There yet. So, you know, for years there was a battle like with Munchhold and
It's become really important. First of all, as we
very strong buzz. But when the AVC kicks in, it just wipes it right out. Buzz caused by this coil? No. So the interference we're hearing is probably interference on the antenna. We're probably hearing what's really there. All this swooshy stuff, unless it crosses the tuning point, which is kind of a weird thing to think about, or if some of the weird stuff is at the IF frequency, it may go through. I'm at the output anyway. I'm at the output end. Let's go to the input end. What are we going to see there? I don't know. Let's take a look. Just another whole set of nonsense going on there. But the receiver is working. Okay, I'm going to attach the ground, antenna ground, even better. Give them a good antenna, get a good result. Okay, I beat that to death and ended up just changing the capacitor. I think I'm going to make it permanent, what's in there. I'm not going to worry about this anymore. I'm going to give up on the weird stuff. I haven't been able to get a grip on it at all. I think I know what it is, but I don't know that I know what it is. The next question for this radio is, what about the missing antenna? To get this kind of performance out of the radio, it's got to be hooked up to a proper antenna. It's going to have to be hooked up to a resonant antenna. Something like this one here. Something like that. So I got to think about what to do. If this radio is just hooked up to a piece of wire, I think it would just sound terrible. It needs a loop antenna of some sort. Okay, well, ever forward, slowly. But yeah, I beat that to death today, and still didn't really. I still don't feel comfortable with the whole thing. Anyway, moving on. Have a good day. I am going to have a good day here, and see you on the next video.